Hello everyone. This should be the 10th video in Law of Vibration series, and especially this is going to be the second video pertaining to astronomy as such specifically. So in the last video we have seen that how if we are placing the planets in a right alignment in probably one of the tools, that is the logarithmic scale. If we are able to align the planets in this proper way, we are probably able to get all the planets mean uh, exactly as per some specific units which are there. So we probably are able to get a new perspective just because of this logarithmic scale. How that is, let's try to understand that. Now, first of all, if we try to place across the planets in the logarithmic scale, we find two specific things which are there, right? So first of all is, as per distance, we come to know how far the distance is there from the planets, right? So this may be said to be in alignment, like we see this, they have been placed properly in a line. Now this is not an alignment which we see over here, but this is purely on the basis of the astronomical unit, and if we try to place them across at as per the distances that they are, so yes, this can be well said that they have been aligned and properly we will be able to see them in a logarithmic scale. Right now, let's try to look it from a different perspective altogether. This would be more like a food for thought. Right, let's try to analyze this. Let's try to understand what is there and how is the behavior overall of the planets. Is it something which is really interesting? So let's say we decide try to have these details in terms of octaves music, whether we are able to find any harmony in terms of the planets, their revolution, their distance from the sun which is there. So let's have some food for thought. Now one thing that we observe over here is, if you see these planets, yes, overall, yes, these planets are more of like together. This planets looks to be like together, and here overall we see a huge gap between Mars and Jupiter. We see a huge gap, right? So that is the first part, and if we try to divide this on the basis of these gaps, we see that this planets, maybe they are more of like together, and this planets which are there, they are more of like together. Now Pluto we don't have as a planet, so these are more grouped together and these are more grouped together. This can be a just wild guess more of, but let's try to analyze on the basis of that, and if we are able to see something really interesting on the basis of that, so let's try to come to those points also. Now, let's try to see it on the basis of distance. So we have something which is more of like an astronomical unit. So that is one rotation of the Earth. So that is the distance which is there, right? So this has been considered that from the Sun to the Earth, this is going to be approximately one astronomical unit. So if we compare on the basis of this distance, what we see is, we see Mercury, Venus, Earth, and Mars, right? These are more of like, if you see in terms of ratio, in terms of distance, and if we try to equate this, let's say for example, this is going to be one, right? So this is going to be more of like one. So if we compare the distance which is going to be there over here, so then probably we find something which is really interesting. So what is that interesting part? Let's try to understand that. So if you see this ratio, which is there of 0.4, it has almost been doubled from 0.4 to almost 0.8. That is the first thing that we see. So this comes from 1 to 2, and this is almost like 0.4 to it goes to 2.5. So this we have considered 2.5, and from 0.4, if we try to multiply in terms of 4, 4 fourths are 16, this is 1.6, so it is approximately coming to 1.5. So we are just randomly considering this. Let's try to have in terms of some ratios. So this is what we get in terms of ratios. Even if we try to compare this on a similar part, let's say for example this is 5, so 5 we consider as 1, 5 twos are 10, 5 fours are 20, 5 6 are 30. So here we are getting two ratios, which is 1 to 2.54, and this is 1 to 4 and 6. So if we try to look at this two ratios in terms of the distance, yes, we see that these are more of like similar ratios. Not much of a difference in terms of those ratios, but yes, we can approximately have that in terms of the distance part, right? So this gap that we see, this more of like divides this into one group and this into one groups. And if we see more of the ratios of the distance and probably this distance, this looks more of similar that we see over here. So this is one interesting thing that we see, and this is more like a wonder or marvel that we are able to see that the planets have been grouped together. Maybe we never thought about this in terms of grouping, but probably this is in terms of pure distance. So this can be something which is really interesting. So let's go to some other part also apart from that, that is in terms of number of days also. So we'll look at that part also as specifically. Fine. So if we look in terms of let's say, for example, this is Earth. So Earth requires somewhere around 365 days. So if we compare all this overall in terms of Earth days, so we have a comparison. Let's say, for example, this is somewhere around 8790. So we have considered this approximately around 100 days. So this comes to figure of 1. Venus 224. So this is approximately 2.5. Earth 3.65. So this is considered 3.5. Mars has been considered 386. So somewhere around 700. Right. So in terms of days, this could be coming, and in terms of ratio, would be coming to 7. Jupiter, yes, because this is huge. So this is 4300. So this is 43. This is 108. This comes to 306, 307, and this comes to 602. Right. So if we look again at in terms of ratios, yes, probably this is something around within a calculation. This is single digit, and this goes to double digit and triple digit. Right. So this is purely on the number of days that it considered that. So this is purely on the basis of number of days which are being required for the planets to orbit around the sun. Right. So this is what it comes to. So again, we are able to differentiate probably into two different groups, again on the basis of the same things that we saw, that okay, this planets probably requires smaller number of days to orbit around the sun, and this planets probably, because the distance is huge, it takes around longer distance. So this is the first part. Let's look at the number of days that it requires to complete a rotation. Right. So if we consider this, Mercury requires somewhere around 58 days. Venus takes 243 days. Right. Earth is 1 day, Mars is 25, Jupiter is 9.9, Saturn is 10.6, Uranus is 17.25, Neptune is 6.1. Now, again, if we try to compare, probably these are faster moving planets, right? What we see is the rotation which is there around its own axis. This is 10 hours. So this is the fastest. Saturn is 10.6, second fastest. Neptune is 16.1, Uranus is 17.2. So these are like 1, 2, 3 fast. These are fast rotating planets around its own axis. Then next comes somewhere around after 4 is Earth. Then we have Mars, which is at number 6, and 7 and 8. So if we consider, yes, these are all in terms of maybe hours or maybe maximum in terms of days. So if we consider 24 and 25, these are of course the fastest. But if you consider for Mercury and Venus, though they are nearest to the sun, right? Their 1 day, that is for rotation, it is huge, 58 days to 43 days. So this probably are very slow moving. In fact, they are nearer to the sun, but the rotation time that they considered are much shorter in contain I mean, like if you consider the time it takes around to orbit around the sun, 60, or this is 90, and this is Venus is 225. So compared to this is almost the same. 58 is again almost the same. So it's like they take around approximately the same time to orbit around the sun also and complete rotation around its own axis. Here the things are totally different for this planets. More of this, in spite being away from the sun, the rotation is much more faster. So this is one really amazing thing that we are able to analyze and see over here, that in spite they being away from the sun, they are spinning at a huge speed. So like the rotation is taking somewhere around within an a single earth day, that is within 24 hours they have been just completing around an orbit. This is really huge compared to the size of the planet. These planets are really huge, but yes, these are faster orbit rotating, and these are probably slower compared to rest of them. Of course, this can be not categorized into that part, but yes, especially these two can be categorized as that. So this is something we see as a differentiation which is there between the planets, right? So this is the first difference that we see in terms of the rotation. And even if we try to see this comparison, yes, this again, or these are like faster orbiting, right, that we saw over here, and these are like slow orbiting. So the time which has been required for orbiting the sun is huge over here, and this is small, right? And in a similar way, if we see, the rotation takes smaller time, and this probably planets, especially Mercury and Venus, takes a huge amount of time. So this is one difference that we saw. This is really, I mean, like as we go closer and try to get into the details, we are able to get some really amazing understanding. So let's try to compare again in terms of maybe harmony and music octaves. So for this, what we'll do is we'll just try to go across through this book. This is Holy Science by Johann Oldenkamp, right? We have already kept this copy on our Telegram channel. So this was being placed around on 11th of February 2023. So this is almost around 6 months back, right, when the Hindi videos have been made. So this is Holy Science. So if you want, you can just join across the unit of technical analysis. So this is unit of technical analysis Telegram channel. You can just join across that and go across on the date of 11th of February 2023, and you would be getting this book, right? You can just download over from there, or maybe on Google, you can go and find out the book over there. So let's try to get, or maybe try to understand few of the things. So here they are talking about harmonies. So let's read this. So this is page number 5. All harmonic ratios are always relative proportions of a multiple of 2 and a multiple of 3. So this is again one wonderful thing that we will be able to know. That's why we need to read books and understand more of the theory part also. That is why Holy Science calls both numbers the universal harmonic ratio base number. So these are like 2 and 3 are base number. Of course, 1 is there, but one is falling into a different category. So 2 and 3 are being considered as the harmonic ratio base numbers. Two harmonic vibrations always have a ratio of 2 raised to power A and 3 raised to power B, where both A and B are always so-called Fibonacci numbers, as described later on in this book. So yes, you can just have these numbers, right? So that is more prominent as such, especially. And before we go and jump to octaves, quint, and chord, let's try to understand more about octaves. So here we go on again, page number 5. Let us start with the principle of harmonic music. A key principle of harmonic music is the octave. So octave is the basic, and we have octave over here. Octave means the whole of 8, since octo in Latin for 8, right? So yes, octave is talking about 8. An octave is a set of 8 consecutive tones. We generally identify these 8 tones as do, re, mi, fa, so, la, si, and then again do. So it starts from do, it goes again to do, and yes, there is a specific ratio between this do and this do. What is that? We'll come to that. The ratio between the oscillation frequencies of the first and slowest do and the second and fastest do is 1:2. So this is again coming back to the same fundamental part, that is doubling, right? So this do and this do, the frequency would be doubling, or if we consider from this do to this do, this would be half, right? So it is almost double or half. The octave is the first harmonic ratio. So if octave is the first harmonic ratio, which is 1:2, The other two harmonic ratios are quint and quart. So what is quint and quart? Let's go over here and try to understand more of in details. So the ratio of octave that we know is 1:2, and the ratio of quint is 2:3. That is 2 raised to power 1, 3 raised to power 1, and quart is 3 raised to 4. So that is quart is 3 raised to power 1 and 2 raised to power 2. That is how it is. A harmonic octave contains 4 quints and 4 quarts, as shown in the figure below. So this is the figure that we'll be able to see. So this is 1, 2, 3, and 4. That is 4 upper bows represent the quints. So these are quints 1, 2, 3, 4. While the 4 bows down represent the quart. So this is like the first one, the second one, the third one, the fourth one. Right. So these are like 4 bows represent the quarts. Now we can understand why the names quint and quarts are used, because quint is like it talks to Latin of fifth. So this is 1 to the number 5. This, sorry, 1, 2, 3, 4, 5. So this is 1 to 5, and this is 1, 2, 3, 4. So 1 and 4. That's how they have been related. Now we can understand why the names of quint and quart are used. Quint is for 5, is a harmony relation between the first and the fifth, while quart is a harmonic relation between the first and the fourth. Right. So this is something really basic that we need to understand, and we need to also understand in terms of the ratios. Right. So now if these are the fundamental ratios that we have, 1:2, 2:3, 3:4. If these are the fundamental ratios which are there for octaves, quint and quart, which are more of in terms of harmonies, right? So this is more like a food for thought again, that do we have a balance among the planets which are there? So all these planets probably, do we identify or maybe have a balance between these planets which is there, because this being away taking longer time for the orbit, but yes, the orbit, but the rotation which is there, the rotation of these planets is faster. This, especially Mercury and Venus, which are the nearest to the sun, they take longer time for a rotation, completion of a rotation. So when they spin across their own axis, they take a huge time compared to this planet. So naturally there is some kind of harmony that we see across. Do we have something called as the music of the solar system, which we are probably able to see over here in terms of the planets, because we see different ratios which are there. These are like fast orbiting, and these planets are probably slow orbiting. So that is not the only difference that we see across over here, but we also see that in terms of rotation, these planets which are there, these are faster rotating planets. Compared to this, these are slower, and these two probably are the slowest. So if this is something which is really in terms of music, a different thing, so we need to understand that, and probably we'll try to go across through this in the coming chapters. So please stay tuned to us, and we'll again get back to you in the next coming videos. Thank you so much. Bye. Take care.